In this paper, we introduce the use of fractional derivatives to simulate cloth deformations underwater. Our approach does not require the simulation of the fluid volume. The introduced fractional derivative term accounts for the memory-laden viscoelastic behavior observed in immersed particles, and the overall cloth model achieves realistic underwater behavior. The fractional derivative terms are fully integrated into the cloth's equation of motion, and the cloth remains a standard mesh of particles. To compare our results with real examples, we recorded the behavior of several pieces of cotton fabric moving underwater. In this experiment, we held the cloth from the top corners, and we applied the demonstrated back and forth swinging movement. You may notice the well-formed bumps consistently propagating along the surface of the cloth. The same scenario is now reproduced in simulation. This first example shows the behavior obtained with a regular cloth deformation model under buoyancy and using drag forces opposing the velocity vectors. The bumps are not well formed, and the result is clearly not similar to the underwater behavior. In this example, we test the use of drag forces opposing the normal vectors of the surface. The result is still lacking the water interaction effects observed in the real underwater cloth. These two models were the ones that achieved the best results among several deformation models tested without the use of fractional derivatives. We now show the results achieved with our fractional cloth formulation. This simulation clearly reproduces the S-shape as in the real cloth experiment. A consistent bump propagation is also obtained. The fractional terms are able to reproduce the inertial viscous interactions between the water and the cloth. The history-laden characteristics of the introduced fractional derivative also enables the long-lasting effects of the applied forces. Here's a side-by-side comparison of the three models. Let's watch again the behavior of the real cloth underwater. And here's our fractional cloth simulation. Here's a frame-to-frame comparison between the real cloth and the fractional cloth. Let's now watch a similar real cloth motion from a frontal view. Here's our fractional cloth simulation. In conclusion, our cloth model is able to reproduce realistic underwater behavior by introducing the new concept of fractional derivatives.